This is lesson U3A03b. By the end of the lesson, you should be able to say I can use AAS to prove triangle congruence and CPCTC to prove parts of triangles congruent. This is the fourth lesson that we've had in the lesson series where we are proving triangles congruent. And by now, this is going to be the fourth theorem that we have in our repertoire of tools to prove triangles congruent. So just to do a quick recap, the first theorem that we went over in the lesson series was side-side-side congruence. Second was side-angle-side. The third was angle-side-angle. And then the fourth one is AAS, which is angle-angle-side. Or, actually, an alternative way of reading angle-angle-side can be read like this. It could be written as SAA. Just as long as you do not confuse AAS or SAA with ASA, because the side here is not an included side, nor is it easy to distinguish which of the two angles are included angles. Neither of those two angles are included angles. Because in order for an angle to be an included angle, we would have to have two sides forming one of the angles. So this is not in any way similar to ASA. This is AAS or SAA. All right, so let's take a look. What I have now, okay, is I have two triangles. Please pause the video for a moment to see if you can solve this problem. We are asked to prove why MN is congruent to QP. Alright, so hopefully you had some time to think about this. So one of the first givens that I notice here is that LN is congruent to PR. And I also have angle M is congruent to angle Q, and angle N is congruent to angle P. These are the three sets of givens that are provided for us within this diagram. Are there any conclusions that we can draw as a result of this? Absolutely. We can then say triangle LMN is congruent to triangle RQP. And remember, the order of the letters matters. So angle L corresponds with angle R. Angle M corresponds with angle Q. And angle N corresponds with angle P. Alright, so we have these two triangles are congruent. And what's the reason, you may ask? Well, that's because of the angle-side congruent relationship. Neither of the side nor angles are included, so that's how we know this is angle-side. As a fifth, for our fifth statement, we can actually immediately jump to saying MN is congruent to QP. And the reason for this is, well, corresponding parts of congruent triangles are congruent. Let's take a look at our next example. So here we have two triangles, and here I'm telling you that ACE is a straight line where points A, C, and E are collinear. I'm also telling you that BCD, points B, C, and D are also collinear on a separate line. Both lines intersect at C. Pause the video for a moment to see if you can figure out how we can prove this statement in this problem here. Welcome back. So, having had some time to think about this on your own, I immediately can tell, actually from the diagram, it is stated that angle BAC is congruent to angle DEC. And the reason for this is, again, for the given. So having thought through the problem a little bit on your own, okay, I immediately can tell that that angle BCA, I'm sorry, getting a little ahead of myself here, I also forgot to state that side AB is congruent to side DE. And again, this is also because of a given. All right. Finally, we can start talking about the proof. Right now I have an angle and I have a side, okay? I need to show, I need to prove there to be another angle or another side to show that the two triangles are actually congruent. So looking at this, I immediately can tell that angle BCA is congruent to angle DCE. And what's the reason for this? This is because vertical angles are congruent. I know that vertical angles are congruent here because the two lines BCD and ACE, they intersect at point C. So immediately I can tell that these angles over here are going to be the same. So now I can, for my fifth statement, I can say that triangle BCA is going to be congruent to triangle DCE. And this is because of angle, angle, side, or side, angle, angle, whichever one you want to use to, whichever way you want to describe this triangle congruence relationship. For my sixth statement, I can then finally say BC is congruent to DC. And what's the reason for this? Well, that's because corresponding parts of congruent triangles are congruent. Let's take a look at our third problem. Pause the video for a moment to see if you can figure this out on your own. So hopefully you had some time to think about this. So the set of givens that I noticed here, I noticed that PR is congruent to TR. I also noticed that angle Q is congruent to angle S. And I know that PT intersect QS at R, which means PT and QS intersect at R, which means we're going to have a set of vertical angles. So if you look at this, okay, I will have a vertical angle here and a vertical angle there, and I can immediately tell that I'm going to have an angle-angle-side triangle congruent relationship. So I know that PQR, triangle PQR, will be congruent to triangle TSR because of angle-angle-side. And then for my fifth statement, I can immediately jump to saying, well, actually, no, I got a little ahead of myself. This should actually be the fifth statement because I said it aloud, but we needed one additional angle, which was PQR, angle PQR, is congruent to, PRQ, I should say. Angle PRQ is congruent to TRS, and this is because of vertical angles. So I know that vertical angles, okay, are going to be congruent, and because of those, of this being a vertical angle here, and I have another angle there, and I have another side, we can then, in our fifth line, say it's angle-angle-side. For our sixth and final statement here, we can immediately jump to saying PQ is congruent to TS because the corresponding parts of congruent triangles are congruent. Let's take a look at the next one. So in this state, for this statement of reason, for this diagram, let's pause the video for a moment and see if you can figure this out on your own. So I know that angle Q is congruent to, so angle Q is congruent to angle T. I also know that angle P is congruent to angle U. I also know that QR is congruent to TS. So immediately, just from this set of givens here, I already know what's going to happen. I already know that triangle PQR will be congruent to triangle UTS. And this is because of angle, angle, side. For my fifth statement here, I can immediately jump to say, oh, PQ is congruent to UT because of CPCTC. For the final problem here, pause the video to see if we can figure this out. So, after having thought of this a little bit, let's see what we can figure out from here. We know that AH bisects angle H. We also know from the diagram here that angle M is congruent to angle T. And these are only two given information here. So, because of the fact that AH bisect, that means immediately angle MHA will be congruent to angle THA because this is the definition of an angle bisector. So those two angles are going to be congruent. And so now that I have an angle and I have another angle, I need a side. So what's the side? Well, AH is being shared by both triangles, so therefore AH is going to be congruent to itself, and this is true because of reflexive property. So when we know that AH is congruent to itself, and this is because of the reflexive property, this is now actually enough information for me to say that triangle MHA will be congruent to triangle THA, and this is because of angle, angle, side. This is actually enough information for me to now say that MA is congruent to TA. And what's the reason again? Well, that's because corresponding parts of congruent triangles are congruent.